Integral control mode. Continuous controller modes part 2. Suppose a system has some error E subscript P and the proportional mode provides a change in controller output K subscript P E subscript P. As we watch the error in time, we note that the error may reduce, but it does not go to 0. In fact, it may become constant. Integral action is needed. Integral action is provided by summing the error over time, multiplying that sum by a gain and adding the result to the present controller output. But if the error becomes positive or negative for an extended period of time, the integral action will begin to accumulate and make changes to the controller output. Request. It is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. In the mathematics of continuous functions such as error, summation is represented by integration. Therefore, this mode is represented by an integral equation as shown, where P0 is the controller output when the integral action starts. The gain K subscript I expresses how much controller output in percent is needed for every percent time accumulation of error. Another way of thinking of integral action is found by taking the derivative of equation 16. In that case, we find a relation for the rate at which the controller output changes. This is the equation 17. Equation 17. This equation shows that when an error occurs, the controller begins to increase or decrease its output at a rate that depends upon the size of the error and the gain. If the error is 0, the controller output is not changed. If there is positive error, the controller output begins to ramp up at a rate determined by the equation 17 as shown. Figure 14 illustrates this for two different values of gain. Integral mode controller action. A. The rate of change depends upon error. If error is small, rate of change is small. If error is more, rate of error is more. B. An illustration of integral mode output and error. This is the error, and depending upon the gain, rate of change the output is changing, integral output is changing for different gains. Figure 14a shows the rate of change of controller output depends upon the value of error and the size of the gain. If the gain is more, the rate of change is more. Figure 14b shows how the actual controller output would look if a constant error occurred. This is the constant error and the controller output. For small gain, small output is coming out, and for large gain, large output is coming out. You can see how the controller output begins to ramp up at a rate determined by the gain. In the case of gain, the output finally saturates at 100% saturation, and no further action can occur. Perhaps a control valve is fully open, for example. Let us summarize the characteristic of the integral mode and equation 16. If the error is 0, the output stays fixed at a value equal to what it was when the error went to 0. This is the 0 error and the output is fixed at P0. If the error is not 0, this is the non-zero error. The output will begin to increase or decrease at a rate of k subscript I percent per second for every 1% of error. Request. It is hoped that this lecture is useful to you. Please press like. Please subscribe.